Just like the dot product, the cross product is an operation between two vectors. And as you already know, we write cross product as A cross B with that X sign in between. The result of a cross product is another vector, and this vector has two properties. First, it is perpendicular to both A and B, and second, the length of that vector is a measure of how far apart A and B are pointing. As always, let's go to the FE handbook and see what are you provided with during the exam. And you can see here, you're giving the formula for the cross product, A cross B. There you go. And there is another formula for the cross product, which is A cross B equals to magnitude of A times magnitude of B times sine theta, and n is the unit vector perpendicular to A and B. And as you already probably noticed, this formula is very similar to the dot product. The only difference is that instead of cosine, we have sine of theta. An important thing to note here is that A cross B does not equal to B cross A, so the cross product is not a commutative operation. Also here, we have represented cross product where we have vector A and vector B and the angle theta in between them. And the cross product, vector C, is actually the resulting vector, which is perpendicular to both A and B. So now let's work on a few examples to sort of better understand this. Find the area of the parallelogram whose adjacent sides are given by the vectors A equals 5i minus j plus 2k, and B equals to 4i plus j plus 3k. So first off, I would like to go to the FE handbook, and if you don't know it, and find the area of the parallelogram. And go here, just find. Let's see if I can find it like this. There you go. So the area of the parallelogram, it is over here, and we're giving two options. We're giving as A times age, which is the longer side, times age, which is the height, or it is A times B times sine phi, which is very similar. If you notice, this is very similar. It's pretty much the same as the cross product, right? The cross product also equals to A, magnitude of A, magnitude of B, times sine the angle between them. So the cross product actually gives us the area of the parallelogram. So going back to our example, I'm going to try to represent this. Okay, so let's say this is vector A. And this is vector B. If I am going to continue and draw my parallelogram here, this is the angle theta in between them. So think about it. Let me write the formula. The formula says that A cross B equals to magnitude of A times magnitude of B times sine of theta. And the formula for the area of the parallelogram is given like this. It's either A times age, which is, age would be, let me add it here in red. This would be age, which falls perpendicular to A, and this is age. Or, of course, if you look at this right triangle, it's very easy to see that if we apply sine of theta, we would get age over magnitude of B. So from here, we can say that H is going to be equal to magnitude of B sine theta. So this is where they come up with this formula, another formula, which is A times H, and H is B sine theta. So in our case, since we're working with vectors, we're going to have magnitude of A times magnitude of B times sine theta. So let's look here. We can easily calculate magnitude of A and magnitude of B. And then the only thing we don't know is sine theta. The way to calculate theta is by using the dot product. So you're going to use the dot product, which is magnitude of A times magnitude of B times cosine of theta. That's one time. And you also know that the dot product has the formula of, let's say, AX BX plus AY BY plus AZ BZ. These are all given in the FE handbook. And from these two equations, you are going to be able to calculate cosine of theta. So cosine of theta is going to be equal to A dot B over magnitude of A times magnitude of B. So this is very easy to calculate, and then you go back from here, calculate cosine of theta, and then you calculate theta as arc cosine of this value here. And then you go back to this primary formula and substitute the angle that you have calculated and find out A cross B, which is the area of the parallelogram. I'm actually going to encourage you to do this by yourself. After I show you the other way we can calculate this, which is easier. The other way we can calculate this is just by using A cross B, which is, as you've seen in the FE handbook, is we just laid out IJK. So we just form our matrix, and we add A first, the vector A, and we have here 5 minus 1, 2, and then B, 4, 1, 3. And as I told you, it's very important, since you have A cross B, to add A first and then B, because A cross B is not commutative, so order matters. And here, let's just calculate the determinant. There are a few ways you can calculate the determinant. You use the way that you know it best. I'll use this way, where I just take the diagonal and I get minus 3i, and then I go this way and I get plus 8j, and then this triangle here plus 5k. And then we go on the other side, the other diagonal, which is minus, and then we have minus 1 here, so it's going to be plus 4k. And then here it's going to be minus 2i from the formula, and minus 15j. So now we're going to add the coefficients with I. Minus 3 minus 2, I get minus 5i. And then j and j, so minus 15 plus 8, I'll get minus 7j and plus 9k. So this is the vector that I get after I do the cross product. So the area of the parallelogram is going to be the magnitude of vector A cross B. And this is going to be equal to minus 5 squared plus minus 7 squared plus 9 squared. And this will get you 25 plus 49 plus 81. And by doing all this, you're going to get square root of 155. So the reason I did this method, it's because it is a lot faster. You can definitely, I actually encourage you to go ahead and use this method here, where you use a dot product to calculate the angle, and then you come back to your initial formula and substitute and prove to yourself that you're going to get the same exact answer. So the correct answer is D. Square root of 155 is the area of this parallelogram. Problem number 2, the expression A cross B dot A is equal to. So this is a property of the cross product and dot product. And if you know it, you would know right away that the correct answer is C, 0. But that's okay if you don't know it. Still, you can solve this. And I would encourage you to just give values to A and B. And I will go ahead and do that. I'll take that A. And of course, to make your job easier, just give very simple values. I'll take A is equal to, say, I plus 2J plus K. And then B, something very simple. Again, I'll take I plus J plus 2K, let's say. And now, very easy, we're just going to proceed to do A cross B, which, as you know, we're going to do I, J, K, and then add 1, vector A, 2, 1, and then vector B, 1, 1, 2. And let's calculate the determinant. So I'm going to have 4I plus J plus K minus 2K minus I minus 2J. And now let's rearrange. 4I minus I get 3I. J minus 2J minus J. K minus 2K is minus K. So this is the vector of the cross product. So now I have, let's call this vector C. So now I have to do C dot A. And this is going to come up to CXAX. We're going to apply this formula plus CYAY plus CZAZ. Let's go ahead and do that. So I'm going to have 1. So this is the A vector. Okay. So I'll have 1 times 3 is 3. 2 times minus 1 is minus 2. And 1 times minus 1 is minus 1. And I get 0, as I told you. So if you don't know the property of the cross and dot product in this case, you just can go ahead and give some values to A and B. Just any, you can actually practice yourself, and I encourage you to do that. Take any other 2 vectors and do the same thing, and you'll get 0. So the answer of this is 0. Problem number 3. 2 vectors A and B. This guy forgot the arrow. Are shown below. Some of the lengths are mentioned in the figure. What is A cross B? Okay. So what are we given here? We are giving the magnitude of the vector A, which is 3. So I'm going to write that down. We're also given that from this triangle, we can calculate B, right? We can use the Pythagorean theorem. So magnitude of B is going to be equal to square root of 5 squared plus 2 squared. So I will get that B is equal to 25 plus 4. And I get that magnitude of B equals to square root of 29. Now let me do something here. So this vector A, I can move it here, right? It's going to be here. This is A. If I can move it here, so this is the angle theta between them. So if I do A cross B, the formula tells us it is equal to magnitude of A times magnitude of B times sine of this theta. Now, how can we calculate theta? Well, very easy, because we have this triangle. So theta, imagine how much is theta from this triangle. If we apply sine of theta, we're going to get that this equals to opposite, which is 2, over the hypotenusa, which is magnitude of B. And we calculated magnitude of B, and it is square root of 29. So here we go. We just calculated sine theta. So we can now apply it in this formula here and calculate A cross B. So we're going to have, I didn't finish here, A is equal to 3. So we have 3 times B, which is square root of 29, times sine theta, which is 2 over square root of 29. And of course, this is also multiplied by n, which is the unit vector. But in this case, it's not required, because looking at the answers, we're going to need the number answer. So here, 29 and 29 reduce each other. So the answer, A cross B equals to 6. So this is our answer, and the correct one is C. Problem number 4. Given our two vectors A and B, find a unit vector perpendicular to both A and B. Find a unit vector perpendicular. So the key here is perpendicular. We know that the cross product gives us a vector that is perpendicular to both A and B. So we're going to have to do here is the cross product. And let's go ahead and first do that. So the cross product, the easiest way when we have the vectors is to just do the determinant, calculate the determinant. And I'll have 10 here, minus 4, 3, 5, minus 2, 1. And I always, if when you're watching my videos, I encourage you to stop the video and try to solve this by yourself, and then see if your response matches my response. So let's go ahead and calculate the determinant. I get minus 4i plus 15j minus 20k. And here we'll have minus plus 20k plus 6i minus 10j equals. So let's regroup now. We have minus 4i plus 6. Going to get 2i. 15j minus 10j, we get plus 5j. And then minus 20k plus 20k reduces each other. So our final vector, or the vector perpendicular to both A and B, is 2i plus 5j. And now, do you know, or do you remember how do you calculate the unit vector? All we have to do is calculate the magnitude of this vector. So we're going to do magnitude of A cross B. This is cross over there. Just don't want to confuse you. Cross B is equal to square root of 2 squared plus 5 squared. And I will get square root of 4 plus 25. And this will get me square root of 29. So now the unit vector is going to be A cross B over the magnitude of A cross B. So in our case, we get 2i plus 5j over square root of 29. And this can be also written as 2 over square root of 29i plus 5 over square root of 29j. Looking at the answers here, we have 2, 29, 5, 29. I see here right away, this is k, so this is, make sure you look carefully at the exam when you pick your answer. So we don't have k at all. We only have j and I, so this is 5 over 29i, so this is not right. The correct answer is A.